Unit 3.2, Lesson 7, Stoichiometry. Stoichiometric calculations involve quantitative relationships of reactants and products in chemical reactions. In order to determine the mass of product made by a certain mass of reactant, and vice versa, it is necessary to convert mass to moles and then back again to mass. It is also necessary to account for the proportions in which substances combine and are formed. As a result of this lesson, you will be able to complete stoichiometric calculations for a variety of chemical reactions. Stoichiometry is the quantitative or mathematical relationship between reactants and products in a chemical reaction. The types of problems you worked on in this lesson are called stoichiometric calculations. When working stoichiometric problems, you can't simply convert grams of reactant into grams of product. This is because the relationship between the amount of reactants and the amount of products is based on the number of moles. So if you are given grams of reactants, you must first convert it to moles of reactants. This is done using the grams of the given amount and the molar mass of that substance. You can then travel through a mole tunnel, which relates moles of reactants to moles of products using mole ratios. This mole tunnel is the only way to move across from the one side of a reaction equation across the arrow to the other side. Once you have used the mole ratio in the mole tunnel, you can then convert that amount of moles into grams, again using the molar mass of your desired product. When working stoichiometric problems, you must remember that grams must be converted to moles, and then moles must be converted back to grams. Grams of reactant cannot be directly converted to grams of product, or vice versa. In our first example problem, we want to find out how many grams of solid calcium phosphate can be made when 25 grams of dissolved calcium chloride are combined with excess aqueous sodium phosphate. In order to solve this problem, we are going to have to find two things: the molar mass of this reactant and this product, and the mole ratio given by this equation. So to first set up our problem, just like we've done in class, we're going to be setting up a series of conversion fractions to take us from one side of the equation through the mole tunnel to the other side. So we first begin with our starting amount. According to our problem, we have 25 grams of calcium chloride. I'm going to abbreviate these formulas. Now we know we cannot directly go from grams of reactants to grams of products. So we must first, in order to enter the tunnel, we must first convert grams to moles. Since I'm starting off with grams, I want to cancel that unit. So in my next conversion fraction, I'm going to have grams in the denominator and my desired unit of moles of calcium chloride in the numerator. The value for this conversion fraction depends on the molar mass of calcium chloride. In order to determine that, I'm going to use the periodic table to add up the mass of 1 mole of calcium and 2 moles of chlorine. And the value of that adds up to 111 grams for every mole of calcium chloride. This will allow us to cancel out grams of calcium chloride and leave us with moles of calcium chloride. So we are now in our mole tunnel. In order to pass through the mole tunnel to the other side of this equation, we must use a mole ratio. So we want to cancel out moles of calcium chloride, so that will now go into my denominator. And I want to use the reaction equation to relate that to moles of calcium phosphate. According to the equation, for every 3 moles of calcium chloride, you will produce 1 mole of calcium phosphate. Remember, since there is no coefficient, just like in math, we're going to assume the number value is 1. So this next step will cancel out moles of calcium chloride and will tell us how many moles of calcium phosphate are produced. So we've passed through the mole tunnel to the other side, and in order to emerge, the problem is not asking for moles, it wants to know how many grams of calcium phosphate are being produced. So now I want to cancel out moles of calcium phosphate, and I need to know what is the equivalent value in grams. Once again, anytime you want to convert from moles to grams or back again, you have to use the molar mass. So from the periodic table, we're going to add up the mass for 3 moles of calcium, 2 moles of phosphorus, and 8 moles of oxygen. If you are not sure how to determine how many atoms of each element there are, please see me after class. So adding up those values, that comes to 310 grams for every mole of calcium phosphate. The next step is to multiply all of the values across the top of our fraction. So we have 25, a 1, and a 310. And the unit left will be grams of calcium phosphate. In the denominator, we have a 1, 111, 3, and another 1. So now all you have to do is simplify the numerator and denominator of that fraction and divide. So your final answer will be approximately 24 grams of calcium phosphate being produced. In the first example problem, we use the mole tunnel to go from the reactant side of the equation to the product side of the equation. The same process as the mole tunnel can be used to go in the opposite direction, from products to reactants. In the second example problem, we want to know how many grams of calcium chloride were needed in order to create 10 grams of calcium phosphate. The problem is still set up exactly the same way. So we start with our given amount. So we are told that we are going to produce 10 grams of calcium phosphate. Once again, in order to deal with the mole tunnel, we cannot go directly from grams to grams, from grams of product to grams of reactant and vice versa. So we must convert these grams into moles. So we're going to use the molar mass of calcium phosphate. Because I want to cancel out grams, it'll go in my denominator. And according to the periodic table, there are 310 grams in every mole of calcium phosphate. We are now in the mole tunnel, and to get to the other side, we're going to use mole ratios yet again. Looking at my problem, I want to cancel out moles of calcium phosphate. So that will be on my denominator this time. And instead, I'm interested in moles of calcium chloride. According to our reaction equation, for every 1 mole of calcium phosphate formed, you need 3 moles of calcium chloride. This will cancel out calcium phosphate moles and has now brought us to the other side, speaking about moles of calcium chloride. However, I'm interested to know exactly how many grams I will need to measure out for this reaction. So I want to cancel out moles of calcium chloride, and I want to know how many grams that is. So once again, I will go to the periodic table and determine the molar mass of calcium chloride, which is 111 grams for every 1 mole. Once again, we're going to multiply across all of our numerators. So we have 10 times 1 times 3 times 111. The unit left is grams of calcium chloride. And the numerator, we have 1 times 310 times 1 times 1. I forgot to cancel out this moles. So once we simplify it, we end up with approximately 10.7 grams of calcium chloride. So in order to produce the given amount of product, we must start with 10.7 grams of calcium chloride. Wrapping up this lesson, how do you convert between grams and moles to determine the mass of product? In order to calculate the mass of reactant needed to make a certain mass of product, it is necessary to convert mass to moles and then convert moles back to mass. Mole ratios assist in converting back and forth between moles of reactant and moles of product. Please remember that molar mass is required to convert from mass to moles and moles back to mass. You can get that information from the given formula and the periodic table. Mole ratios are determined by using the coefficients in the reaction equations.